Good morning or good afternoon, everybody. Thanks for being here. Today I will present part of my PhD work, and today research is entitled Retrofitting of Buildings. What about greenhouse gas emission reduction? Case study of Switzerland. So in Switzerland, as well as in Europe, buildings are consuming almost 40% of final energy consumption. And of this energy, almost 40% in Switzerland is using for space heating. Well, this contributes to almost 25% of greenhouse gas emission of the country. In the last 5 years, Switzerland is implementing the Swiss Energy Strategy 2050 with the objective of reducing of almost 50% the energy consumption and almost 80% the greenhouse gas emission. So today we will try to understand how the current energy retrofit of buildings is helping in achieving these targets. To do it, we will analyze the CECB Dataset. CECB is the Cantonal Energy Certificate for Buildings. It's covered more than 50,000 buildings in Switzerland and is representative of the building stock. So as you can see on the right in blue, we have our sample, the CECB one, and in orange, we have the information from the Federal Statistic Office. And as you can see, for the heating system, the construction period, but also for the regional distribution, our sample is quite representative of the entire residential building stock. We're speaking only of residential buildings. The certificate includes many information about the building. What we will use today is the energy label, the heating system, the construction period of the building, and most important, the actual build energy consumption that is used for space heating and domestic control. So what we did was to process the data set in order to obtain a subsample of building with an energy certificate before and after the retrofit. So this reduced the sample to 1,172 buildings. Then we calculate the greenhouse gas emission using LCA database, the KBOB, that is a Swiss one for Swiss construction. So we were able to, let's say, couple each energy consumption for each building and each heating system, of course, with the equivalent greenhouse gas emission. So we're speaking only of operative energy. And then we analyze the type of retrofit in terms, for example, of heating system installed, the depth of this renovation, and the greenhouse gas reduction that was really achieved after the retrofit. So here we can just have a look to the data, so the information about the subsample we used. So here is 1,172 buildings. As you can see on the figure, most of them are red before. Red, it means low energy label like G, F, or E. And after renovation, they almost all move to green label, meaning A, B, or C. In the table, you can also see a summary of the total energy consumption and greenhouse gas emission before and after. So as you can see, the total energy consumption moved from 80 gigawatt hour per year to 40 after for this subsample. And in the same way, the greenhouse gas emission reduced from 20 kiloton CO2 to 9,25 for exactly always this subsample after retrofit. So let's move directly to the result, as we don't have much time. We started analyzing and trying to, let's say, understand the heating system installed in each building for construction period. And as expected, on the left, you can see that old buildings, so the period of construction is on the x-axis, are using a heating system based on fossil fuel. So in blue, you can see the oil, in red, you can see the gas. And as you can see, until 2000, mostly, basically all the buildings are using one of these two options, so gas or oil. What is interesting to see is that, yes, these are all buildings, but on the right, we can see the installation period of this heating system. And here, what we can notice is that most of this system, so again, blue for oil and red for gas, were installed after 2000. So the old buildings are, yes, using fossil fuel heating system, but new fossil fuel heating systems that are installed recently, and then they will last for the next probably 25 to 30 years. Then we analyze the savings. So to understand, okay, we said we have this information of building before and after the retrofit, how much energy and greenhouse gas emission are we really savings. So how you can see on top, this figure is the final energy and who is contributing to the energy consumption, and below to the emission. So in blue, we have the buildings before. So as you can see, most of the contribution to consumption and emission are coming from the building E, F, and G, because of course most of these buildings before are old, and after they move the contribution to building in B, C, and D. And we can see that this distribution, this pattern is basically the same for energy and CO2. This it means that most of the CO2 emission reduction is only due to the final energy reduction, and not to a really better use of this energy or a greener use of this energy. And this is quite clear when we see the heating system that are installed in this building after renovation, where we can see that most of them are using the same system, so electric, gas, or wood, and the heat pump that are basically not existing before renovation, they are then installed in only 20% of these cases, and this 20% is mostly coming from the oil that before was used in 60% of the cases, and after renovation is still present in more than 30% of the buildings. So this means old buildings renovated with the new system that is still oil-based. We used all this information to create some scenarios for 2050. So in the last row, you can see the objective of the energy strategy 2050, with an objective for Switzerland of 2.6 megaton CO2 equivalent per year, with a renovation rate of 1.9. So each canton in Switzerland is following different approach to reach this target, as each canton is independent under the point of view of, let's say, energy regulation. So we create a first scenario, the number one, that is followed by, for example, Zurich, in which we consider it as a business as usual with a renovation rate of 0.82 and emission of 10.7, so 4 times more the target. Then we have a second scenario with this used, for example, in Bern and Geneva, with a renovation rate that is very similar to the one of the energy strategy, but with a greenhouse gas emission of 5.4 that is double of the target. And finally, a more aggressive policy, let's say renovating all the buildings at least to A or B energy label, is achieving a number in terms of emission of 2.7, so very close to the target, but with a renovation rate of 3.11 that is very, very high, especially compared to the current rate. To conclude very quickly, in terms of emission, we see that most of the old buildings are equipped with fossil fuel heating system newly installed. This is why the emission in terms of CO2 per kilowatt hour are almost the same for all the energy label except A and B. And for these labels, we can really see the contribution of low emission heating system. Regarding the savings, we can see that energy retrofit so far was mainly focused on energy and not on greenhouse gas. So only 20% of cases were installed with heat pumps, so to really, let's say, reduce the greenhouse gas emission. The scenarios showed what we just said. So with a business as usual approach, we are too far from the objective. We need a more aggressive one, but a more aggressive, it really comes with a very high renovation rate. This it means to really boost and push on this aspect. And finally, regarding the energy strategy 2050, as we said, the current retrofit is absolutely insufficient. It's very important, so not only to increase this renovation rate, but also to ensure that the installed system are more efficient in terms of greenhouse gas emission. That's all for me. So thank you very much, and I am here